by the end of the class, you should be able to understand that trigonometry uses the fact that the side lengths of similar triangles are always in the same ratio. And we have done an activity to show us that, although I'm going over again very quick. The other two parts that we're going to do today is label the sides, adjacent, opposite, and hypotenuse of a right-angled triangle when they give us an angle. And the last part is find the sine, cosine, and tangent ratios. So let's see. So a right angle triangle contains a right angle. Oh, sorry. And the opposite to the right angle is called hypotenuse and is the longest side. And you already know this by using Pythagoras. The two shortest sides of a right angle triangle are named with respect of one of the acute angles. So normally what I do is I put my finger in the angle, and when I put my finger in the angle, it's going to touch the hypotenuse and the adjacent side. And the side that doesn't touch my finger is the opposite side. So if you put your finger here, where is the angle, then you're going to have that the opposite side is the sides that that finger is not touching. And then the side that that finger is touching is adjacent. So if your finger is here, you see you have your finger here, so then it's touching this side, which is the adjacent, and you have the hypotenuse. So let's try. So I'm going to do the first one, and you just need to put the name. So first I'm going to find the hypotenuse because it's opposite to the right angle triangle. Opposite the right angle. Then I put my finger on the angle and see what side is touching. So it's touching the hypotenuse and the adjacent, so I can put the adjacent. And the side that is not touching, the opposite to that angle, is called opposite. Let's try again. So I'm going to do the hypotenuse first. So hypotenuse is opposite to the right angle. Then I do the adjacent, that is next to the angle, and then I do the opposite. Can you please stop the video now and do the 3 triangles that you have in your booklet? Okay, after you completed the name labeling the triangle, then we're going to see 2 right angles triangles that have an acute angle and they have the same size, so they must be similar. So for example, if we have 2 triangles with an acute angle of 37, they are similar. As we can see, one is smaller than the other one and is double the size. So the ratio of the lengths of each triangle is the same. So for example, opposite over adjacent is 3/4 equals 6/8. So this part, let's see, this part, 3/4 is of this triangle, so opposite over adjacent is the same than the opposite and the adjacent of this triangle because they have the same angle. Now I can do opposite over hypotenuse. It's the same that we were doing in the activity yesterday, just to show that we have the same ratio. It doesn't matter what size is the triangle. So we have opposite is 3 and hypotenuse is 5 of this triangle. Is the same than having opposite of this triangle, that is 6, divided by the hypotenuse. And the same with the adjacent. So let's see, if I have a triangle that have 21, doesn't matter how big or small it is, it's always the same ratio, you see? So if I have a triangle, doesn't matter if it's very big, very small, with the same angle, it's going to have the same ratio. If I change the angle, the ratio is going to change. but doesn't matter how small or how big it is going to have the same ratio. In this case, 0.97. Okay, so trigonometry comes from the Greek meaning of triangle measurement, and they uses the fact that the side length of similar triangles are always in the same ratio to find unknown sides and angles. So we can use that they are similar, so we can find the other sides or angles. So, for example, if they give us a triangle with 30 degrees, the opposite to that angle is always half the length. So if that's 30 degrees, that's 8. A triangle that is similar to that is going to have 4 as the opposite. And this is a similar, so we know this is 12, that's the hypotenuse, and that's 6. So that's going to be similar. And then we have the 3 trigonometry ratios, that is sine, cosine, and tangent. Now, sine, as you can see it in your booklet, if you have the booklet in front of you, can be abbreviated as this small one, sine. Cosine, you can call it cos of theta, and this is the angle, what it goes here. And tangent, and this is the angle, and you can call it tan. Now, the ratio of sine is the opposite over hypotenuse. And you can remember as so, S-O-H. Cosine or cos have adjacent over hypotenuse. And you can remember as ka. And then we have tangent or tan, and this is the angle of this triangle, and it's opposite over adjacent, and it's toa. So we have SOHCAHTOA. So let's see, let's go back to what we have before. So we have those that you already did. This is what I'm talking about. This is sine, and you can just do it as a sine. And then you have cosine, and it's cos, and tangent is tan of theta. But let's put this in practice. So if we are given a triangle, we need to find the sine, the cos, and the tan of theta. So let's see, I'm going to do this example. So if I want to find sine, sine of theta, and we know for SOHCAHTOA, I'm going to write here SOHCAHTOA so we remember. And I write it like this just because it's opposite divided by hypotenuse. Ka toa. So I know sine is going to be opposite over hypotenuse. So if I'm here, I stand here, and the first thing I need to do is label my triangle. So this is going to be hypotenuse. It's just in 2 colors. Oh my god. And this one is going to be the adjacent, and this is going to be the opposite. That's the first step I need to do. So once I have labeled, I can do sine of theta, which is opposite, which is 4 divided by 5. And that's the ratio. That's the ratio. Maybe I can do it here. Oh, so we have more space. Okay. Now this cos or cosine, cos of theta. That's the angle. Remember this. Let's put it with another color. This is the angle. Just remember that. Oh, that's the angle, and the angle is here. And this is adjacent over hypotenuse. That's why it's important you label the triangle. So that will be 3 over 5. And then tangent or tan of the angle is equal to opposite, which is 4, opposite over adjacent, so it's 4 over 3. And that's all that you need to do. Can you please do the exercise A and B and find sine of theta, cosine of theta, and tangent of theta? Pause the video and please do those. Okay, we have finished this part. So going back to our objective, you should be able to, I'm going to go back here because this is the whole unit. So we have done those three today. To understand that trigonometry uses the fact that the side lengths of similar triangles are always in the same ratio. I hope you understand that one. Doesn't matter how big or small is the triangle, if they are similar, they're going to have the same ratio. Label the sides. It's important that you always do that as your first step and do adjacent, opposite, and hypotenuse. And then find the sine, cosine, and tangent ratios. So we are done for this lesson. Thanks.